you have through the end of this week to wrap things up. If you have not completed or submitted assignments, and these are going to be, even though the due date is past us, you're going to want to finish this up before you log your first attempt of the Module 1 assessment. The Module 1 assessment is going to be posted between now and Friday. You'll have about a 24-hour, maybe 12-hour window to complete this, so it's going to be a little tight. But we'll walk through the things you need to do to prepare for it in today's session. So we are navigating in uncharted territory with a new textbook. And I did want to call out some things in particular. There are some differences. So did everybody see that we have a draft of a study guide?
No, I didn't see it yet.
Okay, so I'm glad I'm calling this out. Over the weekend, we posted this. It is revision 0.6, so drafts will always have a revision number less than 1, right? So if you see 0.6, 0.8, 0.9, we're getting closer to a final version. When we get to revision or version 1, if there's no revision, it's just study guide. That's the authentic, that's the real McCoy. If you have revision 0.9, so just going forward, I'm not always going to use the word draft, but whenever you see 0. That means it's a work in progress, right? And then when you get to just study guide or revision 1, then we get enough revisions, we'll have, I guess technically you'd have versions. Just remember that you want the latest version or revision before you engage the assessment. There are some specific interests that I want to call out, and it has to do with the choice of the author with regard to explaining internet models, networking models. So it's chapter 2. And when I say read chapter 2, I want you to think of it as an Easter egg hunt, okay? As you're going, everybody can see the screen, yeah?
Yeah, we can see it.
So as you're working through chapter 2, there are what I would call Easter eggs. Interesting pieces of information. You know, the explanation about RFCs and how there's a specific RFC that's kind of like the central catalog for all RFCs. That's something you want to note. And I'm not going to read for you. And there are some things that we're going to choose to leave in the textbook and not reflect in the study guide. But you know that if it's in the study guide, it's important, right? Doesn't mean that if it's not in the study guide, it's not important. And if it's in the textbook reading and I make a point of calling it out in class, even though it's not, didn't make it to the big screen on the study guide, this is going to be a course where you're going to depend more on the textbook and less on the study guide at times, right? But I have to call out differences in the textbook. And one of the things that I wanted to share with you is the difference between Comer and our author. Does anyone remember the name Comer?
No, I don't think I remember that.
Okay. CSC443. What course was that? That was the network course, right? And Comer was the author who has been around for decades. Comer is kind of like Kind of like John von Neumann, or Silberberg when it comes to operating systems. So shout out to the legacy industry patriarchs of the computer science disciplines, right? So Silberberg in terms of OS, and in terms of well, there's a team at the University of Wisconsin for operating systems that published an open source textbook on operating systems called the Operating Systems in 3 Easy Pieces, right? Arpasi Dussault it's a hyphenated name, and it's a husband and wife team. Comer is networking, right? Now, our author is arguably one of the leading patriarchs in the cybersecurity reference and textbook arena. But there are some distinctions here that I think are really important to clarify. So he presents 2 network models. He talks about encapsulation, where you have a frame on the physical and data link layer, if we're talking about the OSI model, right? Does this ring a bell for any of you?
Yeah, it does.
Yeah.
Okay, so encapsulation, you have a frame that encapsulates a packet, which encapsulates a segment or a datagram. And I completely appreciate this author's interest. So Messier, he basically says that if you're using TCP, then the sequence of the packets and the guaranteed delivery of a TCP connection, right? So there's 2 primary transport protocols that we know and use on a regular basis. One is TCP and the other one is UDP. You don't see a reference to that here. So the tendency is to talk about a suite of protocols, the TCP/IP suite of protocols. Now, this is consistent with Comer's explanation, right? But then later, this author talks about models. And what we want to do is make a distinction. In the early days of the internet, the TCP/IP suite of protocols, right? It was a new suite of protocols, a new RFC. It was the way to interconnect across the ARPANET, right? The precursor to the internet. And it had 4 layers. And so a long time ago in a galaxy far, far away, the model for internetworking was the TCP/IP suite of protocols, and it was the way to connect across the internetwork, right? And that was adopted by industry. Now, the professional organizations, the standards organizations like the IEEE and the ITU, which is the Telecommunications Union, International Telecommunications Union, and the IETF, in particular the IETF, has a huge role in the internet and in certain specifications. The OSI model is the networking model of choice. Now, a model is a framework. It's not a specific protocol suite. And protocol suites are based on models. So a model is conceptual, but a protocol suite is on the ground implementation of that model for a specific set of hardware and device and networking issues, right? So I want to call out the idea that a model is not the same as a protocol suite. That said, this author chooses to emphasize or contrast the 2 as 2 models. And that's a bit contradictory, or it stands apart from what Comer, the world-renowned industry leading subject matter expert, right? So that's a mouthful. Industry leading subject matter expert, patriarch, right? Comer I think his textbook is in the 6th edition. It's been around for decades, right? He called out a 7-layer model called the OSI model, and you need to memorize each of those. So if you forgot those, you gotta dust that off and get that straight in your mind. You got to know each of the layers and what they do. But then he articulated this other model by industry called the internetworking model or internet model. It has 5 layers. And again, that's a model. It's conceptual. It's not an actual protocol suite. And then Comer also talked about the early days of the internet and how they had a 4-layer model, and it was, it was used by all the industry leaders, by 3Com and Microsoft and IBM and all those industry leaders. And so in your, let's see, in your study guide, I go to a lot of trouble to say, hey, it may seem like semantics, but what you don't want to do is appear to be a novice, right? So it's considered good form when we're talking about OSI and TCP/IP to call out the fact that in this case, we're talking about a protocol suite, technically speaking, and not a model. But in the early days of the internet, it was treated like a model, the earliest model, the only model, the 4-layer model, which evolved into a 5-layer model that's used in industry now. So you have the folks in industry that apply and build, they're the ones that specify and build and maintain networks. They use the 5-layer model, and that's in Comer, and I did not go to the trouble of sharing what that is and how that is. I'll probably put that in an addendum or include a study guide from CSC443. Is everybody okay if I just add a study guide from CSC443 to explain this?
No problem.
Okay, I mean, I could copy and paste it, but what we have here is a case where you have to be able to crosswalk between the models when you're referencing, okay? When you hear the word stack, that's a reference to a protocol suite or the layers of that protocol suite as they're stacked on top of each other with encapsulation, right? So just remember that when you have an entire series of layers for a protocol and all the different related protocols on those different layers, like on layer 5, you have the session layer in the OSI model. Layer 5 is the session layer, which is one row or one layer above the transport layer, right? And the transport layer passes, it unpackages, it removes its segment or datagram, and it passes the contents or payload of its segment or datagram up a level. And on the layer 5, in the OSI model, this is where session initiation, so session initiation protocol is the protocol that's used to do voice over IP. So when you have IP telephony, you have network or data-based phones, like the office phones at our campus, or an IP phone. The session for that voice conversation has to be initiated. So session initiation protocol happens in the session layer, but in industry, that's considered like the application layer. So in the industry, the first 4 layers track with and are analogous to the first 4 layers of the OSI model, but the 5th one in the industry practiced 5-layer internet model, and again, I'll have that information for you in a separate addendum or a separate study guide. That the top layer is always the application layer. So in the 4-layer model, the 5-layer model, and the 7-layer OSI model, the top layer is always application. But in the internet model, the 5-layer model, you have physical data link. There are subtle differences in the names, but 3rd layer is network, 4th layer is transport, and then you have application on the internet model, and then you have session right? And then what comes after session? Anybody know? Application's the top, so what's between 5 and 7? Presentation layer. So the session data is presented to the application. That's a sentence. Everybody repeat with me. The session data is presented to the application layer, emphasis on the word presented, right? Or are we good?
Yeah, we're following.
Okay. So I'm going to try to trick you on the assessment because of the distinctions here and because of all the trouble I went to call out the distinctions, right? So the TCP/IP protocol stack or suite does map to the OSI model, and you have to be able to take an issue that's articulated in one of the models and then crosswalk it over to the other model as needed. So you may need to get very granular in the application layer with TCP/IP. And by the time you walk it over to the OSI model, there are issues that really belong in layer 5, like session initiation protocol or presentation layer, right? There are consistent terms that this author uses with Comer. So the idea of a PDU is the program, it's the protocol data unit or PDU. And those are, named differently on different layers. So this should be a refresher for you, right? Frame on layer 2, packet on layer 3, and then session if you use TCP/IP or TCP, and then uniform datagram protocol. So I went to the trouble of calling out, when you have a guaranteed delivery scenario in a client server environment where TCP/IP is used, and there's a 3-way handshake. And by the way, you have to know this handshake. So in the textbook, it goes to the trouble to explain let's see, the 3-way handshake, right? Now, I do want to tell you about this for a moment. Has anyone ever heard of Fedora? Red Hat, CentOS?
Believe Red Hat.
Yeah.
Yes. So Red Hat Enterprise Linux, RHEL, is the one authorized version of Linux for generic use by the US federal government and many other governments, okay? So you may or may not know that many flavors or distributions of Linux are open source, and they're distributed freely under the GNU license agreement, right? Which itself is kind of a puzzling acronym, right? So if you look at the origins of GNU, it's not Unix, right? So GNU, the NU means not Unix, but it's equivalent with open source. So if you see GNU, that means open source. Now, you can take what you're given under a GNU license, you can modify it and you can pass it along. But when you modify it and pass it along, if you accepted the GNU license up to a point, you cannot say, okay, I have a separate license. The Red Hat Enterprise Linux was adopted and purchased by a company called Novell. And in the early days of the internet, there were small workgroup networks that were set up in professional offices and even mid-sized organizations, right? So you could get very large networks, and there was a competition between Windows for Workgroup and Novell, okay? And eventually Novell figured out a protocol to interconnect all of its networks. So Novell was an early champion. Now, in the Unix world, Solaris and Sun and a few other industry leading companies in the Unix world, they devised this idea that the network is the computer. The network is the computer. That was actually the tagline for a company called Sun Microsystems. And they produced custom hardware and custom operating systems, and basically they were the champions of IP. Eventually, IP gained prominence and everybody adopted IP as the open standard, and then the RFCs were implemented all over the place. But up into the 90s, the early 90s, even mid 90s, you had a lot of organizations that were still running IPX, even on a global level. So you could have a Novell network that spanned the United States, the continental United States, or even international, right? So you could have an IP network that allowed for named resources. So the idea of the IP network is that it works hand in glove with DNS to provide a common naming reference, right? So you can identify based on a name. That requires the use of a catalog within a Microsoft Active Directory. And one of the earliest directories that Novell complained about and tried to sue Microsoft over, they had a global catalog. It wasn't called a global catalog, it had a different name, but the word catalog was in there. And they had a protocol that allowed routing between sites. The important thing to understand is that they both operated at layer 3, which allowed you to pass frames from local area network to local area network to local area network. So on layer 2, even though we're used to seeing IP addresses and we think in terms of packets being routed through routers, right? So it's kind of like a bunny hop. You have so many hops, and that's literally the word that's used. One thing I want you to appreciate is that the local traffic is still transported with frames. So even though you have IP packets that are being delivered across a network, they're still encapsulated inside a frame. And if it's Ethernet, that's a layer 2 protocol. Ethernet and Wi-Fi is a layer 2 protocol on layer 2. The important thing to understand here is that each layer operates independently of the other layers. So it's kind of like that mail carrier system. And I mentioned this in the study guide. So I talk about in the study guide that when the mail is delivered, there's a big mail center, a distribution center, and all they care about is getting it to the right zip code. And their job is done. And so the postal worker in the distribution center in Puerto Rico or here in the Virgin Islands, right? Once they figure out where it's going, okay, which zip code is this going to? They pass the piece of mail, letter or parcel or magazine or whatever, right? They pass the mail along and they're done and they're finished. And it's the job of the next set of postal workers to determine, okay, which street are we on, right? And then once it's on a street, which building are we talking about? And then once we're in the building, which suite we're talking about. On layer 4, one of the very elegant things that the author calls out is this notion that layer 4 is where networking is multiplexed. He uses the term multiplexed. And he describes it in a manner different from Comer. And I think I'm going to change some material in my CSC443 class, because there are some things that Messier, our author in this course, calls out, and he does a very good job of explaining. So once you get to layer 4, that's where you can have 65,536 options, right? You have all these ports. So each network client or each network host can work as a server, providing resources to others. It can be a client because it's connected to another server, receiving and requesting resources, right? Sometimes a given client or a host is exclusively a client. Other times it's a server exclusively. And then there's a third case where everybody is both a client and a server, and it's called peer-to-peer. And I'll probably include some quick notes about peer-to-peer networking or P2P networking in the addendum. In any case, when you have an IP address in combination with a port, and there's a colon, so you have an IP address colon and then 80 or 443 or 25 or all the famous ports, right? You got to know the famous ports. This is from CSC443. It's a refresher. That's called a socket. But if you form a connection, the connection is expressed and established with two sockets, one on the client side and one on the server side. And the two sockets are separated by a comma, and that is how you articulate or express or work with a connection in TCP on layer 4. UDP doesn't do that, right? So UDP is more like, hey, I'm just dropping off the bulk mail. This is to resident at. UDP, think of it as for public distribution. Oh, it's a sales catalog. Oh, it's a flyer from your local community. And those kinds of deliveries are handled by UDP because it doesn't care if you get all of it, and it doesn't, as long as it's delivered. Basically, it just and then, you know, on the other end, if you're missing it, you just ask for another copy. So UDP is very low maintenance, very fast. DNS traffic is basically brokered with UDP to clients, but between DNS servers, it's TCP. That's a really important distinction. In any case, I went to the trouble of explaining that for our purposes in the class, when we talk about TCP, we're not talking about a networking model. We're calling that out a little differently than the author. It's a protocol suite. And in the early days of the internet, because we can't go back in time and we're not rolling the clock back 30, 40 years, we're not referring to TCP/IP as a model, even though some do. In the early days, historically, 30 years ago, they called it the TCP/IP model. But it's not like other protocol suites were based on TCP/IP. So that is, it's considered good form to make sure we're all talking in the same manner about the same thing. And that's one purpose for the RFCs, right? So when I talk about the RFCs, there's a certain RFC that provides information about, it's like an index or a directory of all the other RFCs, right? And I'm gonna go back here. And let's see if we can scare this up. RFC, which RFC number is it? So there's an RFC that has to do with a helper protocol called IP helper. And I think it's 1918 or 1912. That's an RFC number that is good to know. The first request for comment was written in 1969. RFC 1, 1990. Where are we? You're going to use the RFC to do research. So here's about SIP session. So this is when voice over IP started to get in really big, right? There's a lot of network issues. The primary RFC for SIP is 3261, but then you have a follow-on 5411. You can search for the RFCs as well as get a complete list of all available RFCs. And a whole RFC just to provide an index, right? So this is where you want to spend a little time learning this. I'm going to be referencing some of these in your assessment, and I want you to know some of them. So you see this is ietf.org, and when there's a specific reference to an RFC, you do want to take the time to dig in there so you can note some things. In particular, this is an organization where people from all over the world give up their free time to go to conferences to figure out how we're going to be able to talk and play nice together. It's a labor of love, and essentially, this is a good reference when you're trying to figure out what's going on, whether you're network troubleshooting or you're working network forensics, okay? Any questions about the IETF and RFCs? So helper services, ICMP, ARP, DHCP, and DNS. These two work together, this on layer 2 and layer 3, right? So on layer 2, ARP helps associate MAC addresses with an IP assignment. DHCP provides the IP assignment for a given MAC address. Otherwise, it's randomly assigned with something called automatic private IP addressing, or a PIPA. Right? That's not mentioned in here, but that'll probably be mentioned in an addendum by the time we get ready for Friday, the assessment review on Friday. The most important thing to understand is that these two are like the dynamic duo that bridge the gap between MAC address and IP assignment. DHCP has different attributes in its scope that you can also include, like who to use for a DNS server. You can pin down your network security on a huge level if you define the additional attributes of DHCP in the scope, so that it, when a host picks up the address, it also receives the DNS assignment. And that's huge. So if you lock down layer 2 on the local network so that people have to go to a specific DHCP server, and then that DHCP server in turn tells everybody where they have to go for DNS, then you have better security and reliability on the local network and the routed network. Both the local private network that's internal, that's not routed, on layer 2 and layer 3. Any questions about this? So ping is often called echo request. You need to know the different names for ping, and I do want you to know that packet internet groper is another expression that means ping, and your author explains, yeah, but they were really thinking of like sonar and submarines when they came up with that name. So it's convenient that they kind of all fit together. NAT and CIDR, there are specific kinds of NAT that are not, so your most common interaction with NAT is when you have a home Wi-Fi router. And it's actually PAT. So there's 3 flavors of NAT. There's one-to-one static assignment network address translation that you have on an enterprise level. And I explain this again in the other study guide for CSC443. If you're not in an enterprise environment in a big company or a big organization, oftentimes they have a pool of public addresses and they recycle the pool. That's called dynamic NAT. And then if you only have one address, one internet address, public internet address that you have to use for the connections for all your internal devices out to the internet, those have to be multiplexed on layer 4 through different packets using TCP, right? And that's called port address translation. It is an address translation method, but technically the third version of NAT, third flavor of NAT, is technically called PAT, port address translation. Okay. Benefits of IPv6 are explained on page 31, and your author calls out some very important distinctions or differences, like you don't need DHCP to get an address to operate with IPv6. And one of the things that I'm going to call out in the addendum is that there's tunneling protocols that help with the transition between IPv6 and IPv4 that kind of straddle the two different network protocols, and there are known security exposures with those tunneling protocols. In particular, there's one called Toretto, and there's, I'll put it in the addendum. But one thing that I want you to understand is that the things that they've had to bolt onto and add to IPv4 are built into IPv6, including packet security like encryption and verification. So in IPv4, you have something called IPsec, IP security. So that's a type of packet verification and packet encryption with IP networks over Ethernet, right? But in IPv6, that a lot of that's built into the protocol. So one of the most important things, whenever you see a reference to Messier, I'm talking about, so instead of saying the textbook author Messier going forward, I'm just going to say Messier describes such and such. I'm talking about the textbook author, right? So there are two scenarios related to ARP and DNS that present opportunities for a man-in-the-middle attack. Now, Messier doesn't explicitly mention the second one, but basically many public network service disruptions happen with inconsistent or insufficient DNS service. And one of the goals of our network forensics is for you to appreciate just how powerful it is having your own DNS. So one of the things we're going to do in our next module is build a virtual machine that runs DNS, and you're going to operate that in your home network environment, and you're going to see how cool that is and how useful it is without invading people's privacy. So in any case, this is one of the ways that hackers really get a leg up on network traffic. The very good malicious actors know most of the DNS exploits and try to use them shamelessly. So once again, some of you, about half the class has not completed the solution, and in order for us to finish this learning objective by Friday, we have to have everybody submit their solution, right? And I don't want to have to post zeros to get attention, but if you haven't finished your solution, what we want to do is take this up on Friday in our hands-on session, and we want to build, we want to start working on what to do to build the DNS system for your home network as we review your first attempt of the Module 1 assessment. So you will complete the first attempt of the Module 1 assessment by 9 a.m. Friday, this Friday, okay? So please take the time to read this draft of the study guide thoroughly. And at this point, we'll sign off. And are there any questions before we clear today? Given the information that we've presented, does anyone have any observations or comments you'd like to share?
I don't have a question about the content. Just when will the assessment be posted?
I'm gonna finish the revision of the study guide by noon tomorrow is the goal.
Okay,
So by noon tomorrow, we'll have the final version of the study guide, the addendum, and then I'll have a quick and easy, but you're gonna find that the module assessment items are gonna be very specific, but straightforward. We're not gonna try to play, trick the student, or we're not gonna have like an we're not gonna have a challenge where you have to dig for Easter eggs or something like that. That comes later. The nature of network forensics is that you have to scramble and chase, but you gotta get a good foundation underneath your feet before you start to do that, or you just get frustrated. So thank you for asking that question. Any other questions or comments? Okay. Alrighty then. I'm gonna go ahead and clear the room.
all right. Have a good day.
Yep, you too.